Okay, folks, so continuing our review again with ionic compounds, we're going to look at a couple of examples that have polyatomic ions. Now, we actually saw one of those in the previous video. Let's take a look at a couple of others. Okay, so let's look at one where they give us the name. So here we have ammonium phosphate. Now, first thing that I see is this ATE suffix. Okay, so that indicates to me that this second word is referring to a polyatomic ion. Okay, now I look at this first word here, ammonium. Now if I were to look for ammonium on the periodic table, I wouldn't find it. That's because ammonium is also a polyatomic ion. It's the one that we saw that has a positive charge. So hopefully at this point here, you're recognizing that ammonium is a polyatomic ion. So we get our chart and see what the chart tells us here. So yeah, we were right. Ammonium is a polyatomic ion. Let's in fact write down the formula so we don't have to check it again. Okay, and the other thing we want to see is the charge. We see that the charge is +1. Okay, because we're going to have to figure out how many of these ions we need to create our ionic compound. Okay, now we look for phosphate. Okay, and we look, and here we see that phosphate is also a polyatomic ion, okay, which is PO4. Notice here I'm not writing the charges. I don't want to get confused because the charges should not appear in my chemical formula. Okay, I'm going to write the charge underneath, okay, which is -3. Okay, and as we've been doing with all the other examples, once we have the charges, we have to figure out how many of each ion we need. So here this has a charge of -3, this has +1, so I see that I'm going to need 3 of these positive ions to get a charge of +3, which will offset the charge of -3 to give us our neutral particle. Okay, so that means I've got my NH4, okay, which is 1 ammonium ion, but since I need 3 of them, I need to indicate that I need 3 of this whole expression. So that's why we use brackets. Okay, and again, the number of ions, in this case here, indicated by a subscript. Okay, and we only need 1 phosphate. When we need only 1 of these polyatomic ions, it's not necessary to put it in brackets. Okay, you only need the brackets when you need more than 1 of these. Okay, so just to recap, recognize that these are polyatomic ions, get their formulas and their charges, and balance the way we've balanced all the others. Okay, let's move on now to an example where we're given the chemical formula and we have to find the name. Okay, first thing I hope you notice here is this potassium. Okay, it's a metal. Okay, so we know that something that starts with a metal here is we're looking for an ionic compound. However, we don't just have one type of atom in the second part, we've got these 2, and they're both nonmetals. So this indicates to me, this is probably a polyatomic ion, just in case you don't recognize it yet. So again, take your chart if you're not sure, and we recognize OH as being hydroxide. Now notice this is one of those exceptions because it doesn't end in "ite" or "ate", ends in "ide", but what gives you a hint that there's more than one is the hydr, which is hydrogen, and ox, which is oxygen. Okay, so OH. Okay, so this has a charge of -1. Okay, and potassium also has a charge of +1. Okay, so these do definitely balance each other out. But remember, in terms of naming, we don't care about how many there are in an ionic compound. We just need to know the 2 parts. So our cation is potassium, and our anion is the hydroxide ion. Okay, so there you have it. So the important thing here was to recognize that we were starting with a metal, so we were talking about an ionic compound, and to recognize that I've got a polyatomic ion which follows it. Okay, that's it for these.